Hi, thanks for joining me today. My name is Jeff Hatzel. I'm a product manager at Blue Marble Geographics, responsible for Global Mapper Pro and the R&D team. Today we're going to discuss AI-powered tools in Global Mapper Pro. Some of these have been around for a bit and others are newer and still in beta. We'll start by talking about what is AI, or at least break down some of the key ideas in relation to how we use it in Global Mapper. We'll look at the specific tools in Global Mapper Pro that have some built-in AI methods. And then, time permitting, we'll go ahead and take a look at a use case or two in Global Mapper Pro Live. So, what is artificial intelligence or AI? We hear that term quite a lot these days. At its most basic, one way it can be defined is a computer science discipline that focuses on accomplishing tasks which require human-like intelligence. That could be things like pattern recognition, learning from data, problem solving, and image generation like my graphic on the right here. And I'm sure you all see this in everyday life as well, right? It's kind of hard to miss these days. And if we think about just some of the generic ways we might see it, used in our everyday lives, we see it in the healthcare field where AI is being used for image analysis, or maybe you're someone who trains for sport or exercises, and you can use an AI coach or trainer that adapts to your performance and define goals and things like that. When we think about AI a little bit more deeply, two of the main, we'll say, sub-disciplines of AI that we'll talk about today or that are relevant to the geospatial world and our workflows in Global Mapper Pro are machine learning and deep learning. The machine learning side of things is maybe a little bit more straightforward. Right here we have computer systems that are basically trying to learn from data and make predictions and decisions. Generally speaking, it works well with smaller data and ends up being a little less computationally intense. And it also requires more user input before processing. So think of something like providing training data or other examples of data that you're trying to find as an end user. It's very common in a machine learning workflow. A deep learning workflow is a little bit more in-depth in terms of the analysis that it's done, and it requires quite a substantial amount of data. Generally speaking, we can consider deep learning as part or a subset of machine learning, where we're leveraging what's called artificial neural networks, which recognize complex patterns in data. And that's how we can think of those. On the user side of things, deep learning inputs are much more streamlined. But the development side, those of us who are creating the software have much higher engineering efforts required. And that's because typically deep learning models are geared to a very specific task. And so if you're meeting that task, there's very little then that the user has to do to kick that off. Whereas we, the developers, have to build that model to perform that task well. If we think about some applications of these methods, we can consider, machine learning for things like email filtering, where you mark certain things as spam and then future items that hit that criteria also get marked as spam. Maybe on your streaming services, you see shows or movies or whatever that are recommended for you to watch next based on analysis of your previous watch history. And then those of us who, use any sort of GPS app or navigation while we're driving, right? Those apps look at current traffic and travel predictions and analyze those live and historic patterns to figure out time estimates and best routes to take. In our day-to-day life, we see deep learning used in our photo libraries where, maybe photos are grouped by face because we're using facial recognition software to find, yourself or your friends, whoever in your photos. Autonomous driving, now that we're seeing happen more and more, in recognition in response to objects that may be in the path of the vehicle. And then even our banks, fraud detection analysis and spending patterns and things like that. So really, we're starting to see these AI, machine learning, deep learning based methods all over the place. Of course, what we care about is how and where they're in use in Global Mapper Pro. There's two main sections of Global Mapper Pro which have AI-powered tools. That is the automatic point cloud analysis tools, and then the new Insight Learning Engine, which was just released in beta this past fall, has a variety of deep learning image analysis models. To start, we'll go ahead and take a look at the automatic point cloud analysis tool in Global Mapper Pro. Over the years now, many of you have probably heard me discuss, point cloud analysis and classification, segmentation in Global Mapper Pro, because that's something that we really pride ourselves on and how well we do it. In general, what these tools do is leverage a few machine learning techniques that allow really for more accurate identification of objects in a point cloud. And one of the benefits to these methods is that they allow us to be a little bit more flexible in the types of data we're classifying from a variety of sources, right? So it could be terrestrial, point clouds, aerial, photogrammetric, etc. These machine learning based methods give us the ability to analyze that type of data. And also, we've implemented them in such a way that users have the ability to conduct custom training and classification as well. And we'll kind of look at all of that in a second here. So the two relevant, I would say, machine learning components in point cloud analysis are geometric segmentation and semantic segmentation. So geometric segmentation is effectively the segmentation of a 3D point cloud. Sometimes you may hear that called spectral partitioning. What this process does is it helps us identify specific features or objects, if you prefer, in the point cloud. Segments are created based on a variety of point cloud statistics and attributes. So that might be the intensity, the color, and a variety of geometric values, all of which allow us to create and identify specific segments. So on the left-hand image here, all those unique colors are unique independent segments. The second step then is semantic segmentation, and we can think of this as classifying or really giving a meaning or a name to the previously identified segments. So we have some built-in classifications, and those are things, like buildings and trees. Generally speaking, we expect those to fit a certain set of parameters or fingerprints, as they're called. And we expect these to regularly meet the criteria for those structures. Of course, users can edit that. And then a maximum likelihood classification is the process that we use to actually classify those segments into the classes that we have built in here. And one of the benefit of these segmentation-based methods is that it allows us to conduct that built-in classification and then follow up with a custom-trained classification when needed. Users essentially can go ahead and identify an object or objects of their desire. So in this case, you'll see I've identified pools here on the right-hand image in the red boxes. And if we look at that a little bit more closely, when it comes to the initial geometric segmentation, users do have full control over the parameters. They're not required to use them explicitly as we have them built in. And so after they run that built-in classification, which would be the first image here, they can then even further tailor the segmentation to find objects of interest. So in this case, that's what I did for the second image. I was targeting the airplanes here, and you'll see that now the airplanes are made up of a set of colors. Each of those colors is a segment of the airplane. The ones in red are ones I grabbed and selected to say, we're going to use these as our training samples. And then you'll see in the third image, after that training is done, we say go ahead and find all of the other planes as well. And now we've gone ahead and used that custom classification that we trained to identify airplanes. But that again could be applied to really any feature that has a consistent kind of geometric structure within the point cloud. We'll change gears here a little bit away from point cloud analysis and look at image analysis in the Global Mapper Insight and Learning Engine. So currently the Insight and Learning Engine features robust deep learning powered image analysis tools. These currently include 3 built-in models for land cover classification, building extraction, and vehicle detection. And then on top of that, options to fine-tune and fully retrain those models too. So land cover classification allows us to analyze or input a multi-band raster image. And the output from that is a rasterized land cover classification map with a variety of land cover classes which are identified. And we'll look at all of this in a little more detail coming up here right in Global Mapper. Building extraction then is the process of extracting a vector building footprint from imagery. So we'll see our source image on the left is just the RGB imagery, and then on the right we've now extracted vector footprints of those buildings. Not pictured here, this process also creates a binary raster grid, and that's really what's used as the basis for the extraction. So the boundary of that grid where it thinks there are buildings is then extracted to create the approximated building footprints. And then lastly, we also have vehicle detection, and vehicles are detected via essentially bounding box in any multiband imagery. That could be in a suburban setting like here, or in a much more urban setting. You'll see on the right here where all the vehicles have been identified in the imagery itself. But let's go ahead now and we'll move over to Global Mapper Pro, and we'll look at the app kind of live here as I work through it. So in Global Mapper here, what I have loaded now is multi-band imagery, and it's a cropped image. I believe, I want to say this is in Tennessee, but again, that doesn't really matter now. What we're going to look at is some of the deep learning tools associated with the Insight and Learning Engine. We have talked in the past quite a bit about our point cloud tools, and just for the sake of time today, we're just going to look at some of the newer Insight and Learning Engine stuff. But all of those old point cloud related recordings are available on our website and our documentation on YouTube, so you'll be able to find those as needed. So just for reference here, we'll look at the metadata for this image, noting that we have about quarter of a foot, a little less sample spacing. This is very high res. And we have 3-band imagery here. So this happens to be RGB. And it's what we're going to use for a variety of detection and land cover classification right now. These new tools live in their own toolbar. Right now that toolbar only happens to have 3 buttons on it: land cover classification, object detection, and then creating a model, which would be fine-tuning or retraining our models. I ran this earlier just so we didn't have to wait for any processing, but we'll go ahead and pop the tool open and take a look. And one of the nice things about these deep learning tools that I mentioned earlier on in my slide is that when it comes to the user interaction, it's a fairly quick and straightforward process. There is not too much that the user has to do to kick things off. They can choose the type of raster image that they're working with. That holds true for anything, building extraction or vehicle detection. There's different models here, and they should you'd be able to pick whatever you have available here. Each model will have a corresponding description, so you can see any important information about what that model is trained for. For building extraction, you can post-process the vector data. So typically what I'll do is I'll regularize the output, and that just helps us have a little bit more square edges as we might expect a building to have. Vehicle detection simpler. Since we're just creating bounding boxes, there is no extra options here in terms of post-processing or anything like that. It's simply a vehicle bounding box there. And then when it comes to this custom model tab, we'll look at that in a second. That's where anything that we make or fine tune will show up for the respective objects. Running this process is as simple as clicking Start Inference. We won't wait for that now. We're going to go ahead and look at some outputs that I ran earlier. So let's take a look. So the building extraction process in this case technically makes three things. This is what we would consider really the intermediate building footprint map. So these are locations that we think are buildings. The white pixel represents the building. But probably more fun and more useful is for us to look at the vector outputs of the building footprints. We also get the original non-regularized option, but since I chose to post-process it, I have that saved as well, and I could see each building has its own footprint. Maybe we got a little overconfident right there. That's probably not a building in the road, but otherwise these buildings look pretty good. And these are, again, traditional vector features. You can save them out of Global Mapper or work with them, however else you may need to. The vehicle identification process, and there's not a ton in this neighborhood. We can see some in the streets here, a couple maybe parked over here too. Then identifies the bounding boxes around vehicles and where they are on the imagery. Overall, does a really good job, and this imagery is technically a little lower resolution than what our initial models were trained on, but not by much. And we can see we identified mostly all of our correct vehicles in the images throughout the neighborhood here. A lot of them parked at houses and things like that, rather than looking at a busy road. And so the last thing I want to look at is the land cover classification. We did not look at that tool initially, but it's set up very similar to the others. Again, you would choose your band count and the model you may need to work with, and it should pick this automatically. I don't have a 4 spectral band image loaded, so it will automatically figure out which data set is loaded, and if I had multiple, I could choose kind of what layers I wanted to work with here if I didn't want to work with all of them. One of the interesting things about this, I always like to point out, is generally speaking, when we're performing analysis, we often think, oh, higher resolution is better. It will get me a clearer, more accurate output. In the deep learning world and with deep learning models, that's not always necessarily the case because the model is trained on a very specific type of data. The reason I'm showing this is it's going to be incorrect, and I want to highlight the process of fine-tuning it and cleaning it up where there's some mistakes. We saw earlier we were looking at about a 1/4 meter resolution in the imagery. This model was originally trained on about 1/2 to 1 meter resolution. So the data we have is much higher resolution than the data the model was trained on. And so the original output, while pretty good for never having seen data of this type before, we certainly see up on the northeastern side of this data set, right? There's some confusion up here between water and bare ground, and some of the other bodies of water don't do a great job of being identified. So what I did then is I used our fine-tuning and retraining tools to create a fine-tuned land cover model. And what I can do is I can generate training data. And I did this a little earlier, but we'll go ahead and take a look. And you'll see I've already drawn on here. We can see I drew and corrected this, water and shrubbery to be bare earth. I cleaned up what the pond should look like. And there are a variety of quick ways to do this. Again, this assumes you may have ground truth data that already exists, and you don't ever have to do any of this. But I wanted to highlight the ability that it can all be done. So maybe what we want to do is just very quickly, I'm going to say I want to swap colors. So I'm not going to rerun anything. That takes a bit of time. But let's say I, in fact, want for example, we're going to just go to unknown for right now, and we're going to change water. So I'm going to go ahead and draw a box around my water, and it will change just that water to the unknown class that I just set. Could always undo that if I make a mistake. I don't really want to save that as water. But really handy ways to get in there manually. Not only can you switch colors, you can fill color and draw an area, or apply a certain color to a certain region in large groups. I really like the replace value because it lets me target one type of incorrect class and kick it over to another class. So let's, for example, say, these areas in the forest here are probably, you could argue they're barren or maybe low vegetation. For our sake, let's say they're barren, and I want to change any of the impervious here, as it's called currently, to barren. So even if I get other classes in here, the only things that are getting changed are the impervious class that I targeted. So a really quick and handy way to clean up our data sets. You can always validate your change, and that'll make sure that the classes you provided match your model that are built in. And then once that's done setting up the fine-tuning or the retraining, there's a few parameters here available to us. The iteration is how many times the model repasses over the data with your updates. Batch size, generally speaking, we don't have to think about too much because the tool will set that to the maximum that your hardware can support. But generally speaking, larger the value, it can process more samples at once and it'll run more quickly. Typically, we don't have to touch that. And if you ever need to, you could also perform a full training as well, and that will totally redo the model based on your new data set. We're not going to sit and wait for that to run now, but essentially it would run through the training process, and I'll start it quick here just so you can see, you confirm your control imagery and your control ground tooth, and then the process goes ahead and kicks off, and this will take a few minutes, so I'm just going to go ahead and cancel it now because we don't need to watch it finish right now. So that's about all I wanted to cover right now, but let's go ahead and wrap up before I run out of time here. If anybody is interested in using the Global Mapper Insight and Learning Engine, anybody who currently has a Global Mapper Pro version 26 license, you should have the Insight and Learning Engine license built right into Global Mapper, and you can go ahead and use it. That built-in license will be valid through the end of February, at which point that'll then get extended or renewed, assuming you update to version 26.1 when that comes out. And if you're in maintenance and support, that shouldn't cost you anything at all. Again, if you have Pro, you can go and look at all of the point cloud analysis tools that I talked about earlier as well. So please feel free and go ahead and take a look at that and get hands-on with that too. So just to wrap up here, Global Mapper now has a variety of AI-powered analysis tools. Those might be the point cloud-based tools with machine learning methods for geometric and semantic segmentation, or in general classification, and then of course the Insight and Learning Engine, where we have deep learning powered image analysis tools. So please go ahead and take a look at those tools and keep an eye out. I'm sure you've already heard today, but we have a release coming up shortly here in the next few weeks, and both of these tool sets will see some updates with that as well. Thank you.
Alrighty, so I'm going to welcome Jeff back for our live Q&A.
Hello.
Hello.
How are you doing today?
Doing well, thank you.
Good.
How are you?
Good, thanks.
I'm glad. Alrighty, so we have someone wondering which versions which versions of the software include the Global Mapper Insight and Learning Engine? I think you covered that in the session, but just for clarification.
Yeah, good question. So we released it with version 26. So that was back in September. So anybody with active maintenance and support of Global Mapper Pro in version 26 will have access. And that will continue now with 26.1 that's coming out in a few weeks as well.
Awesome. Thank you so much. And then we have people wondering about if this is in any of our training materials so far. I don't believe it is, but I figure you can answer that.
Yeah, I don't believe it is yet either. We may have touched on it in one of our new What's New courses that's online. But other than that, it's not in our official training yet. Uh, we're kind of waiting since the tool's still in the beta phase, to have it a little more complete before we do that.
That makes a lot of sense. So the next question that we have is someone is wondering if the deep learning tools that you mentioned can provide an accuracy report.
Great question. As of yet, we don't have that exposed or provided. And essentially, what we're doing, and I'll use either vehicle detection or building extraction as an example, we set basically a confidence value, and if the tool thinks it is confident enough to call something a building or a car or whatever the case may be, it will then include it in the estimate. What we're looking at doing as we further wrap up the tool is maybe exposing that setting to the user and looking at how maybe some of those values could be added as attributes to the vector feature. So you'll have that information with the tool.
Awesome. Thank you.
Mhm.
So, what sort of resolution and or other requirements does one have to meet to do manhole detection with the segmentation-based AI methods?
Are we, I don't know if that's a point cloud question or an imagery question. If it's point cloud, the answer is as long as you have enough points that represent the feature of a manhole cover, shouldn't be a problem. On the imagery side of things, since we don't have a model trained yet on manhole covers, you would probably fully retrain the vehicle detection model, and you'd want to have high enough resolution such that you could actually see the manhole cover, right? If the manhole cover is 1 pixel, it's not going to work. Um, so I would think anywhere in the range of that, sub-foot resolution that we have the tool using already would be sufficient for that. But again, not something we've officially tested yet.
Cool. Um, Another like resolution-based question that we have you found an ideal pixel size for deep learning imagery? I've found other image deep learning softwares that have trouble with less than 5 centimeter pixel imagery.
That's a really interesting question. And I think initially what we've seen is that depending on the data you're using to train your model and the quality of that data, you have a little bit of flexibility in terms of resolution. However, the big caveat there is what you're trying to find. Buildings, right, are much larger than a manhole cover, for example, right? So you could get away with probably lower resolution in that regard. I wouldn't say that we've found a one size fits all approach, and I don't know if that exists yet in the field of deep learning, but um, I would say that we've seen so far that it can be variable based on the training data, the control data, and what object you're trying to identify.
Great, thank you.
Mhm.
So we've got another question wondering, is it possible to simplify building outlines by reducing the number of vertices to the bare minimum and keeping the interior angles 90 degrees?
Yeah, that's a great question. So that's what the simplify and the regularized settings attempt to do within the running the tool itself. And then we have our own like simplify tool. You could re-simplify outside of the tool itself. Um, but one of the things we're looking at is trying to figure out a way to improve that directly in the tool. Where that gets tricky is, the fidelity to the data compared to what you want your smooth building footprint to look like. So that's one of the things we're looking at now in that regard.
Cool. So, does the Insight and Learning Engine allow for using derived input variables like NDVI or combinations of elevation and imagery products?
That's a stellar question. At this point, it does not, but that is something we're actively looking at where, either we or users can provide multiple types of data for the same region in an attempt to um, more accurately find objects or detect whatever it is they're trying to detect. So that's an active area of research for us.
That's great. So, I'm going to wrap it up after this next question, but
Okay.
we've got someone that says the point cloud processing tools look great. Um, how much computing power do they need to utilize it?
That's always the fun question. It varies depending on what the data is you're working with. Um, Obviously, when you're working with very large point counts and file sizes, you're going to start thinking about your memory constraints because these are can be memory intensive processes. 32 to 64 gigabytes is never going to be overkill. Generally speaking, the more cores you have on your CPU, the quicker the process will run, or really any process that's multi-threaded. So that's another thing to consider. And we do have, I should say, Meg, we do have that um, listed in our documentation for recommendations if somebody's concerned with looking at those specifically.
Awesome, that's great. So I think that that actually wraps us up. So Jeff, thank you so much for your presentation and thank you for answering those questions.
Yeah, thank you.
We'll make sure that we get to any questions after the fact, but I hope you have a great day. Thank you so much.
Thank. Bye.
Up next, we've got Mariah presenting the academic scholarship ceremony.